we can actually call something generative when it does like hundreds or thousands of options automatically in the background and chooses the best options that we will target or we will have our goals set into them. So we have actually multiple definitions. I'm not going to get into the details of the definitions, the naming. I'm going to just get into practical part. So I'm going to go ahead and launch Dynamo. I'm going to create a very simple example that'll actually make it very easy to you to understand how generative design works. I simply have an area, let's say something like this. Now I want a rectangle, a simple rectangle shape to be fitted in this area with the maximum area possible. So I want to fit a rectangle in this place. I'm not sure how will it work if I rotated it, increased the width and the height. I'm not sure how will it go, how is it going to be the final output, how is it going to be. So I'm going to let Dynamo do this for me, or let's say the generative design. You do have to understand something. Generative design is something exaggerated. It's not something magical. It just randomizes things in its background and tries to pick up the nearest goals we set. So let's start by simply making the input, or let's say preparing the input node. However, one final note before I get started. To actually be able to use the generative design in 2021, you have to have a separate license for it. That license is not purchased as the same license as Revit. This is from Autodesk side, just to let you know that. There's also a beta version called Refinery. You can access it from the beta Autodesk site, just to let you know. All right. So the first thing we need to know that we will have something called generative design in this add-ons place. Let me open it and go to selection and click on select multiple or select multiple family instances. Oh, sorry, select model elements, not family instance. Select multiple model elements. We're going to select them and finish. You will see the finish from the option bar. A quick note here. The select model elements that comes shipped with Dynamo behaves differently. It does not have the finish on the option bar, so this is something to notice. Yeah, the inconsistencies in Autodesk stuff, it's alright. So the select model elements, we have it here. Let's grab the curve, the element curves from them. This is very, very, very basic stuff yet. Let's flatten the list so we have a single list, or not multi-list as it is here. Next, let's get the start point of every one of these curves. Now we're gonna create a polygon. So if there was a curved line and you would want to create a polygon from it, I will recommend doing a segmentation to the line. There are some nodes that could be used for this. There's the synthesize package. There are segmentation by distances. You can use it, but I'm not gonna include this case in here. So I have this polygon. Let me get its center. And this is the center of the polygon. All right. So the rectangle is gonna be from that center. However, this center should change. I don't know where is the best center. So let me create a translate node that will translate this point in X and Y. I'm not very interested in the Z axis. Now the second node in the generative design workflow, your input in addition for the selection input has to be sliders. It cannot have a number as an input because it doesn't know what to guess. However, if you put a slider, it will know that I want it to guess the following values. However, I want them to be in the -2. So I'm going to write -100. But there's the third note. I don't recommend putting huge values because just imagine if the computer is going to guess randomized values, it's going to take lots of time. If you gave it some unreasonable big values for the case you are using here. So the whole thing here doesn't exceed like 30 meters, the whole thing here. So it's 22, so I'm gonna actually make it minus 40, let's say, and plus 40, or 30 by 30. So this is a note to actually just keep in mind. Let me just say it 40 because the horizontal is, the vertical is more. All right, so the limit of the x translation, let me say it x translate, is minus 40 and 40. So if I put it here, I can see the point moving like that. I'm gonna create another y translate, and here. So now I can actually make generative design toggle between the positions of these points. Now I'm gonna create a rectangle, and this rectangle requires a plane. So I'm going to create a plane. So I'm not going to get in deep into Dynamo stuff themselves. I'm just more interested in in explaining the generative design part of it. All right. So this is the plane. I've put it. And next, I'm going to have the width and length. So again, they're going to be number sliders. This is going to be the width, and this is going to be the length. So again, the same note applies. Do not insert a huge amount of numbers if you don't need them. Just for confirmation, can you still hear me?
Yes, yes.
All right.
Yes.
Perfect.
Yeah.
All right. So what am I going to do now? I'm going to actually create, let's say, the same amount, like minus 40 and plus 40, because I'm not going to probably need more, or let me just test it. Right, as you can see, so, there's no minus here, it's a width, just the positive. It'll be minimum 1, so I would not need more than this. The same applies for the length. I will not need more than the 40 length, I guess. Yeah, so just take this as a note. Alright, so of course this helps, these steps. If you mate 0.01, Dynamo will have more options to mess with, which will require more time. You will have to remember, I think probably most of you know, that Revit is really weak in processing, so it uses only one core, so you will have to make it optimized as much as possible. Alright. Although I'm not sure if the generative design actually do parallel processing, but the general note applies. It is weak in processing. So the next thing we're gonna do is rotating. I'm gonna give it the ability to rotate by a base plane for the geometry, and the base plane is gonna be the same plane, and the angle also has to be a slider. So this is gonna be rotation angle. Let me just save the file. Any crashes happen, just testing stuff, or let's say generative test. Alright, so the rotation angle, if you thought about this, I'm not gonna need more than 90. So I'm gonna go here, and as you can see here, let me just change stuff just to make sure that I'm not gonna need anything else. I think 90 will actually cover everything up. So yeah, 90. However, based on my trial and errors, the rotation angle is kinda okay to give it a full 360, as it sometimes helps the randomization. Yeah, so it doesn't actually really makes difference here. So just for the sake of performance, I'm gonna leave it as 90. So now we have the rotation ability, the width and the length, and the position of the center of that rectangle itself. So those are my actual variables that are gonna change, or I'm not gonna change them personally. Dynamo is gonna do that and find the best solution within the rotation angle as well. Now I have finished my inputs. They are pretty straightforward and easy. But the thing is, you will have to score your goal. Now, when is the acceptable solution and when is the not acceptable solution? So the first goal is the area. I want it to have the most area possible. So I'm going to simply patch the rectangle. Just like that. I think it's pretty straightforward as well. And next, I'm going to actually report the area of this rectangle. So this is my first evaluation number. This thing, this area has to be the largest possible. Let me just colorize it something different. So this is a goal. And the other goal is the center of the rectangle, which is that point, or the middle point here we can see, has to intersect with the boundary or the space inside this boundary I have itself. So I'm gonna patch again the whole these things. Let me just the polygon, the big polygon here. So this is another patched polygon, and I'm gonna evaluate does intersect with the point, and it always must be yes with this point, the translated point. It always should be yes, because if it is out, then this is incorrect. After all, it's a computer, it's not a human. It can actually do this and tell me, oh, I gave you the biggest thing you want, and it'll be something stupid like that. There's just a little mistake here. I have patched the not rotated one. This is the one that should be patched. Yeah, so I'll have to force it to actually know when it is correct or not. So now it's incorrect. It's false. This is not correct. Let me just get it back where I want it to be. So this is now true. So this works. However, the next thing to evaluate is this patch, the rectangle itself, should not intersect with that polygon, with the initial polygon we created, with this one. It should not intersect with it. So the same patch would be evaluate the intersecting of this one, and it should return to false. All right, so if anybody has any questions regarding this, let me know now. Let me just decrease the width and the length so you can easily understand it more. Yeah. So let me hide the other stuff that might mess your head. This is the patch. This is the rectangle. Not this one, the rotated rectangle. And this is the polygon. All right, and this is the point. So now it is accepted. Why? Because intersecting, well, there's a bit of an error, a logical error here. Let me just wrap it up.
Okay.
Yeah. What's the logical error in here? It should not actually intersect, not with the patch. I'm sorry. It should not intersect with the borders because it's always intersecting with the patch. So just let me fix this like this. All right, so let me wrap it up very quickly so everybody can be aligned with me. So when is this accepted? When is the rectangle accepted as something to continue guessing with? The midpoint of the rectangle has to intersect with this patch, the big patch, the boundary patch. The next, let's say, condition is that the wanted rectangle must not intersect with the borders, with those themselves. So, if those two conditions happened, the rectangle is always inside these borders, and that's it, I guess. That's it. So, you can ask me now.
No, that's it.
All right.
Okay, thanks.
If you have any question, let me know because I'm gonna get into Python stuff now.
Okay. About the selecting nodes, we just able to use only generative design selecting nodes.
Well, some tests showed that I could use other selection nodes, but as I told you, things are not getting very recently consistent, so I'm sticking with this for now. And it has a percentage of 100% acceptance. You can select with other nodes, but I'd prefer using this. It's even more friendly, more user friendly, as it has a finish in the option bar, unlike the other selection nodes in Dynamo. If you're asking about other selection like choosing all category off or something like that,
Yeah.
it works. It works.
Or Python nodes.
It works.
It works.
It works, but you will figure out that it's useless. Because generative design is really specified to work with single cases. Imagine I'm working with multiple boundaries here. It's not gonna be able to work because I will have to have x1 translate, x2 translate, x3 translate, y1, y2, y3 for each single boundary, and it's gonna consume more time and it's gonna be useless. If you just, if you just imagine that, it's not gonna be very helpful. So that's why I think generative design team made specific selection nodes because they already understand that those are the most used ones for generative design.
Okay, thanks.
Hey, Karam.
Yeah, sure.
Hey, I would like to know what's the name of generative design package. It's generative design, or you can find inside the search.
Those are generative design extension, generative design Revit. But to be honest, I didn't install them. They come pre-installed. They already come pre-installed.
Okay.
Yeah, so as soon as you launch it, as you launch generative design, they already install themselves. So don't worry about that.
Oh.
You only have to have the generative design activated. All right. So the thing is, the fourth or the fifth note we have to understand is I cannot accept false and true, or generative design cannot read false and true. It reads numbers as an output. So I'm gonna simply create a small Python script that has those two as an input. And the correct condition is as it is now. The input 1 has to be false, the input 2 has to be true. Just to wrap things up, why does this has to be false? This indicates that my rectangle does not intersect with the boundary. The second one, why does it have to be true? Because it indicates that the rectangle middle point has to be intersecting with the big patch this. So it knows that it is inside the place I want it to be. Alright, so I'm gonna just output 0 and 1. How am I gonna do that? I'm gonna simply say, let's say input 1 is in, or let's say input 1 is in 0, input 2 is in 1. in 0 and in 1 are the respective those, in 0 and in 1. And this the very, very simple if statement, if input 1 equals to false and input 2 equals to true, then I'm gonna out a successful launch. So it's gonna be 1. And else, any other conditions, I'm gonna output an unsuccessful run or unsuccessful or unwanted condition, which is 0. I'm gonna delete the last one here and simply just for the people who didn't use Python in Dynamo before, out means writing this, it's built in Dynamo Python scripts, means it'll output this. So I'm going to save and see now it's 1. This is accepted. Let me just change to something not accepted. Like this has grown larger than it's supposed to be. It's now 0. And why is it 0? Because it intersects with the borders, and this converted to true. This is not accepted. Let's decrease its size, and you're going to see that it's now 1. Now, let me just make it outside of this place. This is not accepted. 0. So I think it's pretty obvious now. We have a perfect set of, let's say, variables and a perfect set of goals to reach. So my goal is very, very simple. Having this as 1 with the maximum surface area. What's gonna change to achieve that? Everything here. The X and Y and width and length and rotation angle. All of them will change and give me that. So before I start the generative design part itself, if you got any questions in the Dynamo part, let me know before I get going.
That's okay for me.
Alright,
Thanks.
let me continue now. So, how to install this script and prepare it for analysis? Well, I'd recommend actually grouping stuff just for organization. It's nothing major, but just group stuff. So to make generative design understand that those are the inputs or the variables, you simply have to right click every one of them and click is input, is input, is input, is input, and the final one as is input. Now I have all of them as input. Now to make it understand that those are the output or the goals, simply is output. Right click is output. It's pretty straightforward. Don't make anything else output and input unless you want it to be like that. Now, I will start the generative design and install it. It will fail because there's a mistake I have made here, and I have intentionally made this mistake because it drove me crazy today. So, simply, all right, go to generative design here as you can see it. You will see export for generative design. Click on it. It tells you validation complete. Graph is ready to export. Now, I'm going to assume that this didn't happen. I'm going to assume that it fails. And to show you how it fails, I'm going to enter it again. And I'm going to directly go to generative design export. No, it insists not to fail. I'll just do that and I'll make it fail. Right. So it failed. If you find those issues, simply you need to run the code. Other types of failures you might actually see is actually it asks you directly to make a run. Just run the graph. So it just guides you to do whatever needed. You don't have to think much about it. Just go to export for generative design. So I'm going to run it now. It's validated now. So this is a question, a tricky question. As a rule of thumb, for now only, let's say clear cache data, but it won't make a difference for now because this is the mistake I have made here. Export. And now I can use this inside create study. Close Dynamo, open create study. And you will see it here, generative tests. Those are the built-in stuff Autodesk shipped Revit with. I'm gonna start generative tests, and there's something I have forgot here. Does anybody know what's missing? There's something very important missing here.
The little center of the square?
The input itself, the selection input is not here. How am I gonna select stuff? How am I gonna select the lines? I'm gonna have to get back to the script and I'm gonna simply put right-click on the input node and make it is input, the same as I did with everything else, with this one, like this. Now, let me just go back. No, it's not gonna work while going back. Every change you make, you will have to re-export. It's just like snapshotting what you're doing. Generative design, export for generative design. All right, run it, validation completed. It doesn't matter here, export, and close Dynamo. So this always have to happen in this way. So, create study. I'm gonna do lots of changes now just to show you or to confirm this idea. Generative test, I have the select multiple model elements now, here. I can select everyone and finish. Let me just start with the generate button here. I'm gonna explain a lot in this area. Let me just click on generate and let me show you that it won't work.
I understand they needed to use select generative design nodes now.
All right, here you go. Very empty thing. Now this thing actually drove me crazy in the earlier days, really. The thing is, it's still buggy, at least not consistent, but always remember to use remember. This is called remember. So remember always must be used after Dynamo grabs the data from Revit. Now, where is the place that Dynamo grabs the data from Revit? It's the element curves. After it grabs the geometry from the model elements, refinery or generative design will actually ignore this, so it gave me empty results. But if I plugged in remember, now this is driving everything else, it'll work. To show you what remember means, remember actually works even if you disconnected this now. It still remembers everything here. So this is the most important note to use with generative design. Always use remember node after grabbing the geometry of Revit model elements. Now,
Excuse me, Karan.
yeah.
Why not after the select elements node?
Because after this, I will not still have grabbed the geometry itself. And in each run, Dynamo will re-grab this thousands of times, so it doesn't make sense. So it simply doesn't run it.
Then that means the data remember node is used to Dynamo geometry too.
Exactly. The data remember is only for Dynamo geometry. To be honest, the data remember doesn't have an exact documentation of what it does accept. It has some bugs too. It doesn't accept polygons. It changes polygons to polycurves, so you'll have to explode. Those stuff will come by practicing this thing. You will understand what it accepts. But as a rule of thumb, make it remember the geometry converted from model elements of Revit. It could be actually after the flatten.
And then it's only to Dynamo geometry.
Yes, definitely.
Okay, thank you.
All right, I'm gonna click on run, and now this will work. Now, I have made some change. What to do? Generative design, export, and this question now is important. How should cache data in all remember nodes and select nodes be handled? Now, if you clicked on clear cache data, Dynamo will clear everything out. When do you think we should use clear or keep? If anybody has any ideas, let me know now.
When the Revit geometry changes?
Well, actually, there won't be a case where Revit geometry changes and then Refinery re-grabs it. It doesn't support that. But if you are using a single project, or this script is going to be used for, let's say, global projects. So if I'm going to use this for many other cases, I'd prefer to clear the cached data. It'll reduce the size, improve the performance, and it'll be cleaner. Now, if the case is gonna be sticked with this exact boundary I have worked on, the data, remember, will keep the data it grabbed earlier, and it'll save time eventually. So this is basically the main reason why you should change between keep and clear. I'm gonna assume that I'm gonna use this in many other cases. So I'm gonna click on clear. You can see that everything is now emptied. This selection was emptied, and everything will actually be empty. It doesn't show it empty in the remember, but it's not here anymore. Now I'm gonna close this and click on save and exit. All right, I've opened something here. All right, so I'm gonna go to create study now, and generative design, generative tests, and let me just wait for this to appear. The select and select. I don't know if somebody noticed, but in the earlier test, the lines were already pre-selected. Why is that? Because in the earlier test, I clicked on keep data. Now I cleared the data, so it requires me to select anything new. I'm gonna select those. Finish. I'm gonna click on generate now. Let's wait for it. Alright, as you can see, we got some shitty result here. Why? It thinks that the rectangle should be this stupid line here outside of the boundary. Why? Why my variables, my outputs aren't working? You can see clearly it outputs 0 where it should output 1. So now comes the goals. Let me just close this and create another study.
You need to choose to maximize.
Exactly, the maximize. Just for the sake of making it really easier, let me just change the name of Python script to acceptance status. Just for make it very better user friendly. Double click on this. Let me say acceptance, and it should be 1. Just to make it easy for me to read. I'm gonna export again, run the graph. Alright, I'll have to select again. So this is something you need to understand whenever you do a change. Run and clear cache data export. So that's it. I'm gonna close it now again and create another study. Now these are the major concepts we're gonna get into now. In the generative tests, we have here X translate, Y translate, width and length and rotation angle. Let me just select the lines first. Now, in the X and Y and width and length and rotation angle, it says those are the variables. You can simply untick and choose a constant value, but no, I'm gonna leave them all as my variables now. Now the goals. How much is the needed surface area wanted? It should be the maximized, the maximum one. How much is the acceptance value should be? It's also should be maximized. Why? Because there's only 1 and 0, and I want it to be the maximum, which is 1. Now, the next part is the constraint. This is very useful. If you want a specific area to reach, the minimum and the maximum ratio, it'll tell generative design to prefer those ranges. I think it's pretty straightforward and pretty great. The acceptance, it should be 1. How about we just input 1 as minimum and 1 as maximum? What does that mean? I am sticking with 1. I want to kill myself to reach 1. Why 1? Because it is the accepted value in my study. If anybody has any question now, I prefer you ask me before I continue.
The generative design algorithm consider numbers always as doubles. That's because you set these constraints.
No, it works with floats. It's alright.
Okay, but it's only floats.
Yeah, it's numbers. Actually, it's basically numbers. Yeah.
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 Okay.
All right. So the next part, which is another major important part, the population size and the generation and the seed. I'm just gonna leave them as they are now, and we're gonna see why will we need to edit them next. Let me click on generate now and see how the results will look like. There comes the important part. So it finished while giving me another shitty result. Why is that? Why is that happening? Although this is accepted now, it's 1, but it's not what I wanted. Let me explain how generative design works and create another study. So in the test, let me just set the maximize the gain, the everything I want again, and choose the lines. So here's the thing. The population size and the generation. The generation means like one generation, it contains many population, many tries and errors. As I told you, it's randomizing. So if I made population as 20, it'll try 20 times to give me the best result. Then it will take the best of those 20 times and it'll upgrade it to the next generation. And the next generation will try another 20. And it'll get the best one and keep upgrading until it reaches 10 generations. In this specific case, the population nor the generations were enough. Let me increase it something dramatically large, like 150. It'll be rounded to 148 to some limitation in the algorithm itself, which doesn't matter actually. The generations, let me make it 50 generations. So it's gonna be much more accurate and it'll spend much more time to reach what I want. Let me click on generate. And there will be many important notes here.
Karam,
Yes.
that seed number that we saw.
I will talk about it in the next run. Now let's watch it here. As you can see, it's giving me a shitty result again. But yet, you can look here, 3 out of 50. It's testing. It's trying its best now. It reached 6 out of 50 now. It's still testing, 7 out of 50. Now, it sticks with the best result it came up with. And it slightly adjusts this result to give better options. It'll keep doing that until it reaches 50. Let's just wait for it. It's not going to be very long because the example is pretty simple. So as you can see, it's now clearly trying to adjust itself. You can, if you were satisfied, simply click on pause study and it'll stop. As you can see, we have different examples. Now, that example is gone. Why is it gone? Because it proved to itself that it's an absolute or an obsolete and not needed result. It sticked with the better one. Let's just...
That's my question now. What about options generated? How can I visualize them?
Yeah, in this example, it won't give you other than 1 or 2 options because I told it to give me that. However, there are other options we're going to see now. It's simply called randomize. It'll give multiple options. Let me be clear on something. I'm going to just show you multiple tests here. In this specific tests, it's pretty easy to guess what's the best option. In more complex tests, it will give you lots of things to visualize. As you can see now, it's trying to give me stuff, but it's still keeping, it still removes them because it knows they are not needed anymore. Just let's wait for this a little bit more. And I think when we are satisfied, I think we're satisfied now. This is the best rectangle we can get in this area. You can try your best. You will never get better than this one. Let me just pause it here. Or as you can see there, it gives me pretty slightly You can see the values here changes. They are almost all the same. Yeah, with very slight differences. The X translate is 2 and 2.1. Very, very slight differences. But in general, those are the best options, which all they seem almost identical. Alright, so I'm going to pose it. So, this is pretty straightforward example. You can see here I'm not going to get much into the filtering because I'm not getting many options here. But you can filter results. I'm going to talk about this in the next example. Now, one of you asked me about the seed. What was the seed? Well, the seed is simply where does it start randomizing. If you change this seed to something else, it will start differently than the last time. It doesn't actually really matter unless you do repetitive tests on the same case study and you want to be really different in timing of giving the results based on the luck you have, of course. So it doesn't actually very much make a difference. Now, the important note here. Is that normal that I used 150 population size or 148 with 50 generations? It's pretty huge. But my algorithm here is clean. It's not going to cause headaches to the generative design itself. In that case, the generations and the population size could be increased with not actually worrying about anything goes wrong or spending much time. Now, other case study is, let me just, if you have any question before I can continue, please let me know now. Yeah, you asked me about the visualization of the options. Yeah, there are multiple options here you can do. Instead of optimize, you can randomize. Of course, this depends on your algorithm. If you want your algorithm to randomize, you can say how many solutions you want. You can click on 1,000 solutions. It's all right. I'm going to click on 60, create another study, and you will see that it will give me billions of stuff. But they are not optimized.
Yeah, okay.
They are not optimized. The optimized solutions might be multiple optimized one for slightly complex cases. In this specific case, it sticked with one because it was sure this is what I needed. And it was sure that this is the cleanest one. And my code was actually clean. All right. So the other example here. This one actually comes in the Dynamo primer, the refinery primer. There's a primer they created. It's called refinery primer. You can actually check this example here and download it. However, the algorithm used in this example isn't very much, let's say, fast. So it didn't reach what I wanted really fast. Let me just launch it and show you what I mean here. So the same applies, but everything is prepared here. Select the room element, and let me just generative design, export for generative design, run. Everything is prepared here, so we don't have to take notes of everything we said about an early example. Let's just run it, and now let me just clear, or let me keep the cache data because I'm gonna stick with this example here. In this file, I'm gonna export. Now, let me just get back here and close this now. Create a study. This distributing lights. There are multiple variables. You're gonna have to dig into the file itself to see what those are. As you can see, the room is already selected. Why? Because I said keep the data. I will need the minimum unlit floor points and the minimum overlit floor points. So the area is not overlit and not unlit. I'm gonna click on generate now. Now you will see that it will actually really spend efforts in trying to get me the best results because this case is pretty much heavy. However, the specific algorithm used in this example, I haven't gotten the time to investigate it yet, but I have created a better one. But the better one is still buggy a little bit, but I have gotten the chance to take some results out of it. Let me just show you the results as soon as this starts to appear. And there will be another important concept to understand here. Let's see, let it generate. It's clearly taking more time than the previous example. Alright, it started. As you can see now, it will try to give the yellow things are the light sources, and the points on the floor are the light intensity on the floor from those sources. Let's just give it some more time. So it will try to get its best. In this case, it will give many other solutions, but as you can see, the lights aren't actually, well, placed in a good way. And to make them be placed in a good way, you will have to increase the population, the generation, and you're going to have to wait lots of time. So the other algorithm I made, which I'm going to show you just right now, will actually initially place great lights. Then it'll test on them. Let me just pause this because it's going to take lots of time. And let me open the other case, which is the other algorithm, but it's not ready yet, or let's say not perfectly ready to be used with refinery yet, because I haven't yet stabilized the remember data and those stuff I've just talked about. It's called dangerous test. And I'm gonna select the room and I'm gonna hit on play. So what's different from this algorithm I'm trying to make here is that it initially gives better outputs. What does that help? There's a very important rule in generative design. If your code is clean, then and your options are, let's say, logically, programmatically generated in a very, let's say, logical way and very near to what you actually want, you will save hundreds of minutes just actually trying to get to what you want. That's just take this as a note. So there is a huge part on your mind. You should have a brain when you create an algorithm. It's not something magical. You should work on this to have something very optimized initially. Then make refinery help you to generate more cases. So that algorithm I made, it generated this one. I was able to grab that. It actually made an overlit floor points of 0. There was no overlit areas, a little bit of unlit areas, and the total number of fixtures is 28. Of course, there are other changes like the lux and other factors to mess around inside. Other example, as you can see here, it gave me multiple things to optioneer from, to choose from. And this one, well, aesthetically is the best solution for this specific case. So it depends on the case if you want, if it gives you multiple best options and you can choose from them. Other case I have used with generative design that was 2 years ago, before it was called generative design, it was called refinery, is this one. So this one actually is, I'm not gonna get into the details, but I'm gonna get into this place. There's no geometry here. It's only math. Now, what's different between using generative design in math and using it with geometry? In this example, there were billions of options, like 1,000 generations and tens of thousands of population that was actually completed in minutes because there was no geometry. It was only pure math. The math of this is pretty complex. I'm not going to get into the details of it because it has a couple of formulas, but what's different in this case that I was interested in the fast results. I was really running out of time, and I was interested in really fast results. I wanted the best number of people between all the choices with the least prefabricated segments count. So I have like 350 by 150, and this was a better here, even better like algorithm or run. So it's just you can use it with math. Now this math can propagate into something better and better and better until it actually gave a 300 denoms neighborhood project. So it really depends on what you are thinking about, how you're gonna achieve it. It could be geometry, areas, math, or any other studies that you can actually see shipped with the Revit itself as an initial case study. Yeah, so any questions?
A simple question. The geometry showed in generative design window is the same with the Dynamo window?
Yes,
Okay.
it is the same.
Okay.
I think,
So man, thanks to you, this meeting. Fabio is here.
yeah.
Okay.
Oh, can you hear me, Karam?
Yes, I can.
Okay, now okay. I have to change the mic. Okay, well, thank you very much for your time. It was very nice. And these small tricks I know maybe can make people take a lot of time to understand and figure out these tricks to make it work.
Right.
So I'm very pleased that you could make it for us. This, and also we have to thank Lucky a little bit to make it more easy
Yeah.
for tonight. Yeah.
Yeah.
And if would you like to? Do you have any way people can contact you?
Well, I
If they
think
want,
I
or
think
you are available.
I think well I'm available on my LinkedIn and my email, which is Karam at aecedx.com. This is my work email. Anybody can contact me there, of course. And of course, just final notes here. The generative design is publicly new, so many changes might happen with time. Just to consider that. But the whole notes we've talked about are actually more like rules of thumb, just to consider. But as I said, many things are changing. Bugs are being fixed. I expect the remembered data in future might be much less used compared to right now. So just to consider, changes would happen.
Okay. Well, thank you everyone for attending. It was very nice. We have an average of 30 persons online most of the time. So that was very nice, Karam.
Definitely.
Thank you again.
Thank you everybody for attending. It was nice.
Okay. Shukran.
Thank you very much.
You are
Thank you very much.
you are
This is
most
very
welcome.
nice.
All right, then. Good night, everybody.
So, good night. Good sleep
Good
now.
night.
Because it's like 2 a.m. for
Yeah,
you, yes?
yeah, 2 a.m.
So,
All
thank
right,
you very much.
all right. Good night.
Bye, bye.
Bye, bye.
Falou, pessoal. Até mais. Muito obrigado pela atenção.
Valeu, Fábio.
Bye,
Obrigado.
bye.
Cara.